Lesson 6.3, Radian measures. Now, the intent of this lesson, or this section of the unit, is to develop a relationship between the degree and radian measure of angles. So that's the intent. It's really to look at the relationship between degrees and radians. The key concept, the ratio of the length of the arc swept by a point on the terminal arm of an angle in standard position to the radius of a circle formed is the radian measure of that angle. In other words, the intent will show that 360 degrees equal to 2 pi radians. Now, we will try to achieve this intent here, or to fulfill this intent, through looking at 4 sub-goals. We're going to look, one of the goals is to convert degrees and radian measures. The next goal is to determine the trig ratios of angles in radians. The third is solve the problem involving radians and trig ratios. And finally, determine angle measures given a terminal point. So through these 4 ways, we will be able to develop a relationship between the degrees and radian measure of angles. So this is our main focus, and through these ways we are going to achieve that goal. For today's lesson, we'll be working on the first one, which is a converting between degrees and radian measures. So the intent today is to convert between degrees and radian measures. At the end of it all, you will be able to check your understanding number 1 on page 489, and questions 5 and 6 on pages 494 and 495 of your textbook. Your prior knowledge, just to review that, you remember arc length. We looked at arc length of a circle, in other words, a part of a circle is equal to the central angle divided by 360 degrees multiplied by 2 times pi times the radius. The circumference of a circle is 2 pi times radius, or 2 pi r, and the circle has 360 degrees. So to activate our learning, let's look at the scenario. Here we have a diagram. It shows a circle, a radius 4, and a terminal points for a certain angle. So we have a terminal point here. So we have R, P, and Q. We have those terminal points. We also have terminal points. You can look at, here's a terminal point if you wanted, or here, but we're just looking at these 3 terminal points that given. We're going to use a diagram to complete the table below here. This is from your textbook. So here we have a table below it. Let's focus out a little bit here. So we're going to use this diagram to complete this chart here, table. So angle BOA, so BOA, we'll find what that angle is, and we'll find that in pi radians. So the first thing you want to do, let's look at angle BOA. And we want to find, so B, this is B, O, and A. We can tell us 90 degrees, but we want to find this arc length here. We're going to find the first arc length. So to do that, we can tell right away, this is 90 degrees. It's perpendicular. So the length of arc length BA, we're looking at this here. And remember our formula, right, is the central angle divided by 360 degrees multiplied by 2 times pi times, in this case, it tells us the radius is 4. So we have a radius of 4 here. Oops, these are all 4. So we work this out now. So BA, so arc length BA will be equal to 2 times pi. So this is 90 degrees. This is 2 pi. Next, we look at angle POA. So we have P, O, and A. So we're going to look at this angle here. So we need to find that angle. We can't tell by looking at here, so we're going to find that angle. But if you look straight down here, so we know this is our hypotenuse here. Now remember, this is your x, your y, which is equivalent to cos and y sine. So we know from here to here will be 2. That's your x value at this point here. This is 2. Now this opposite theta will be 2 root 3. So it's easy to work with cos. It's a whole number. So to find this angle, now once you find this angle, then you will find the arc length. So that's what we need to find, right? The arc length of, is it PA? So to find the arc length of PA, we need to find the angle of P0, POA. That's why I need to find angle POA. So if we take a look at, we see that cos theta is equal to the adjacent here, 2 over 4, which gives us cos theta a half. Now remember from your trig ratios that cos theta equal a half, so it's 45. Would it be 60 degrees? Now remember, that's from your unit circle. And I'll suggest this is the back of your booklet, the unit circle. If you're going to go back here and zoom in. So here we have cos theta is equal to a half. So it's 60 degrees. Okay. Cos theta equal to half, so the reverse. And so this would be sine 60 degrees. So we can conclude that theta, so theta is equal to 60 degrees. Now later on we'll find, we can convert that in radians. So leave that as, so this POA is 60 degrees. Now we've got our angle. We need to find our arc length. So our arc length, which is PA, will be equal to 60 degrees over 360 multiplied by 2 times pi, and the radius here is 4. So that will give us, to sum out, is 4 pi over 3. So arc length PA is 4 pi over 3. And we look at angle QOA. Now we know this here is the terminal arm of R, which reflects. Now to find this angle here, we know BOA is 90. So by finding this angle reference angle here, we will be able to find the angle QOB. And therefore that will give us angle QOA. So angle QOA, find QOY. So you can find this angle here, or this either one here. We can end up with all of them. Then we're going to add to 90 degrees. So in this case here, we know, now if you look at this point here, this is my cos, and this is sine. Now, what is cos negative root 2? Now, if you go to your chart here on your, so cos negative a half, or even sine negative a half, is 135 degrees. So from this, we can tell. You can also work it out. This is the other way is to find OAQ. So I'll go ahead and find OAQ, but the easiest way to do it is to go on. But if you know what cos negative 1 over root 2 is, you know it's 135 degrees. But I'll show you that it's also equal to 135. So let's look at this now. We have cos, right, which is opposite over hypotenuse, right? So this is our, sorry, cos is adjacent. So here we have theta here. Our adjacent here is negative 2 root 2. So cos theta in this case would be negative 2 root 2 over 4. Which is negative root 2 over 2. Okay. And negative root 2 over 2 is equal to 45 degrees. So this is 45, this is 45, this is 90, gives you 1/4. So 45 degrees plus 90 degrees is going to be equal to angle QOA. Now we have our angle, and we need to find our arc length. Our arc length for QA. So arc length QA is equal to 135 degrees over 360 multiplied by 2 times pi times 4 the radius. So QA is equal to 3 pi. So here's we have 3 pi here. Now the last one, which is the reflex angle ROA, and rather than going all the way out and solve again, we know that cos theta, if you look at ROA, I think it's angle here, is root 3 over 2. Now, root 3 over 2 will give us 330 degrees. So theta so root 3 over 2 cos is 330 degrees. So the arc length, so we have 330 degrees here. So the arc length would be, which is arc length R is 330 over 360 multiplied by 2 times pi times the radius is 4. And that will give us what, 22 pi over 3. So the arc length RA, 22 pi over 3. Now this is precise. You can approximate it by working out, if you approximated it, what would it be? Let's see here. 22 pi divided by 3, 23.038 approximately. Okay, so far we've looked at finding the arc length in degrees. And here notice we found it in radians. And this is radiant, and we'll talk about that in a minute. So 3 pi. But in degrees, we have in pi and radians. So it's leading into the whole concept of radians and degrees. When we're discussing radians and degrees, these are two ways of measuring angles. Degrees, 360, and this was developed many thousands of years ago, divided up a circle into 360 parts. They're called degrees now. But it could be any number. It could be 400, 500. The other way, which is more mathematicians love, is the idea of the radians. Measure the angles in radians. And we'll discover that 1 radian is a measure of the arc length of a circle. The arc length of a circle is equal to the length of the radius of the circle. So in other words, if I have a circle, radius here, and the radius here is 1. Okay. So the arc length here, right, if this is 1, then this is pi radians. So this will be pi. This is 1 radian. It would be 1 radian. So when the radius is 1, the arc length is 1, or a ratio of 1 to 1. In other words, you could have had another circle. Now this isn't the concentric circle. If you were to have another circle that's concentric to it, hint here. I'll just do another one on the side here. If I have another circle, this is 1 radian. If this is 2, and the radius is 2. So the arc length is 2. That's what I meant by a radian. And I'll show you how that came about. Let's start off with something that we all know, a circle. And a circle consists of a radius, which is half the diameter. So here you have a center. You center the circle here. And half of the diameter, which is diameter from one end of the circumference. Now, first of all, we call this a circumference, which is the perimeter of the circle, really. So we have the circumference. We have the center of the circle. The center to the circumference of a circle is called the radius. Now, the distance around a circle, the circumference, call that C, C for short, is equal to 2 times pi times the radius. Okay, so let's write that down here. The circumference VRENC of a circle is equal to 2 times pi times the radius. Or C is equal to 2 pi r. Now, a circle, you have 360 degrees, which we said earlier, in a circle. So we have 360 degrees. Put that in the corner here. One circle. So the distance around the circle, which is the circumference, so 360 degrees is equal to C. Because that's the circumference, right? If you go measure the angle, so one circle has 360 degrees. So we can put this here. So C now, we change that because C is 360. 2 pi r. Now, if we deal with a unit circle of 1, the radius is equal to 1. Okay, so the radius here is 1. Now we make this 1, a unit circle. So we can have, if you do a sketch here, 1, 1, 1, and 1. So you have 1. So it'll be 0, 1, 1, 0. Negative 1, 0. And here we have 0, negative 1. So we have a radius of 1. Okay. So now this becomes 360 degrees is equal to 2 pi, and now this is 1 here. It's a unit of 1, and we call it radian. So now 360 degrees is equal to 2 pi radian. Now radian is a number, right? Yeah. So it's a number. That's like a non-entity. So there we have it, right? 360 degrees equal 2 pi radians. So we have this relationship between radians and degrees. Now, if we take this degrees, 360 degrees, which is equal to 2 pi radians, then 1 degree, so 1 degree will be equal to, that here, 360 degrees now is equal to 2 pi radian. So we divide by 360 degrees by 360 degrees, which is equal to 2 pi over 360 degrees. Now, this becomes 1. So we have 1 degree. If we simplify this now, 2 goes into this 180, is pi over 180. So this is the first one. So 1 degree is equal to pi over 180. So that's something you need to recall. Okay. Let me look at radians now. So 1 degree, so we can see here 1 degree is equal to pi over 180 radians. So here we have 1 degree, finding 1 degree, what is equal to. Next, we look at radians now, reverse now. So if we go back here, we have, this is what we have at the beginning here. I'm going to move this around, so I say 2 pi radians. So 2 pi, a little bit of r there, indicate radians, is 360 degrees. Now, I want to simplify for 1 radian. Now, what is equal to? Now, if I were to divide this by 2 pi, so that we get here, we get 1. So 1 radian is equal to now 360 over 2 pi, which is simply 5. Okay, I'll write that over here, give myself some space here. We'll have 1 radian is equal to 180 degrees over pi. So 1 radian is 180 over pi, 1 degree is pi over 180. We'll use these 2 facts to work out the difference between radians and degrees. Okay. So if I were to convert certain angles, let's look at one example. Let's look at an example. We want to convert 60 degrees. Now, if I have 60 degrees, let's look at an example here. You have 60 degrees. And I want to convert this to radian. Now, we know that 1 degree is 1/8 of a pi. So I will take basically taking your degrees and multiply by pi over 1/80. So this is converting degrees to radian. Notice whenever you're doing converting degrees to radian, the pi will be your numerator and your denominator will be 180. And the reverse will be whenever you're converting radians to degrees. So now this will be 60 multiplied by pi over 180. Notice the degrees will cancel, and this will give us pi over 3. So 60 degrees is equal to pi over 3. So let's look at another example where when we are doing the reverse now. We are going to convert, so we have example 1 here. So another example, when we're changing radian, let's say I have 7 pi radians. I'm going to change it to degrees. So now 1 radian is 1/8 of a pi. So you take your radian and multiply by 180 over pi. So here I have 7 pi multiplied by 180 over pi. Notice that pi divided by pi is 1. Now you have 7 times 180, which gives me, what would that be? 7 times 180, even 1260 degrees. There are a few other examples in your booklet for you to look at. So that's converting degrees to angle, to radian and radian to degrees. So here's a summary. In a circular radius R, a central angle of 1 radian is obtained by an arc length R. In other words, 1 radian, as I indicated in the previous one here. 1 radian is when you have the radius and the arc length to be equivalent or the same, so 1 to 1. So a central angle theta radian is obtained by an arc length pi r. Now that's what I'll be doing next. I'll show you when we were looking at arc length, we were using proportional method. I'll show you how to use radians now, which is much simpler. And these, 1 radian is 1/8 over pi, 1 degree is pi over 180, pi radians is 180, and 360 degrees equal to pi radians. Now, just want to make sure, look back at this now. If you look at the unit circle, and here are points here, origin here, this is 0, 1, this is 1, 0, this is -1, 0, and your y here would be 0 and -1. If you look at the circle, it has 360 degrees. This is 180 degrees here. So half a circle is pi. A quarter of a circle is pi over 4. Right? 3/4 of a circle is 3 over 2 pi, and a complete circle is 2 pi. That's why we can say pi radians is 180 degrees, which is 180 degrees here. This is 360 over here. And 1 radian is approximately 57 degrees. I'll show you what I mean by that. So let's look what meant by arc length, which I indicated here. Okay. So remember we said that arc length, 1 arc length, or a radian is the arc length equivalent to the radius. So this is 1 here, that's 1, and that's 1 radian. So 1 radian is when the arc length equal to the radius. Now, how do we go about finding this? So let's look at a circle. We got here. And here we have R. So we have 1 radian here. And from here to here is your arc length. So indicate R. So it's your R. And so that's 1 radian. Okay. Now, the arc length, as we know before, if you look at the arc length, we said it was the central angle divided by the circle, which is 360 degrees, or 2 pi. Now we've learned that 360 degrees is 2 pi radians. We will, okay, let me just leave this here as this circle. 360 degrees multiplied by 2 times pi times the radius. Now, we know 360 degrees is 2 pi radians. So we have our central angle. Now let's say our central angle here is, let's do another one here. It's theta. And this would be our arc length. Now this is the radius here. It's the same. So the central angle here is theta. And this is radian. Now we're measuring radians now. We're not measuring degrees. So now we're going to change 360 degrees to 2 pi radians. Okay, that's what 360 degrees is equal to. So we want to find A, the arc length. Multiply by 2 times pi times the radius, you put at R. Now, if you were to go back now, let's remove the pi's. We put an R there. So 2 pi multiplied by 2 pi times the radius. Two pi can divide 2 pi into 1. So we have A is equal to theta times the radius. So now we can find the arc length without using the proportional method. Once we know the theta, which is in radians. So these two must be, remember, they have to be in radians. You cannot do one without the other, so they have to be in radians. So theta, right? So theta has to be in radians. And A and R must be the same unit. So in other words, you cannot have different units for A and R. So to make this, to illustrate it now, so if we have a circle and we have theta in here, and this is R, then the arc length here, A, we can find by theta. This has to be in radians. Okay. So now we know how to find radians. So now we have this formula now. A is equal to theta R. I never like to say it's or. It's theta looks like an O, but it's not an O. But that's how we are memorizing it. A is or, equals or. So the arc length is equal to theta times the radius. And theta has to be in radians. Now, if it's in degrees, now you have to convert that to radians. Let's look at an example. So determine the arc length when we have the radius is equal to 15 centimeter and theta is equal to 4. So you may have a circle. You may be given a circle like this here, and you said, okay, here we go, center. The radius here is A, and you're given an arc length of 4. And tell you the radius is 15. So we know from our formula, A is equal to theta R is 4 times 15 centimeters. So A is equal to 4 times 15, which is equal to 60 centimeters. Far much easier than what we were using before. Okay, now here's another question you may be asked. You're given a scenario. Here we have one. It's now 130 degrees. Now it's not in radians. And the radius here we use 6.7. Find A. So determine the arc length when R is equal to 6.7. That's centimeters. And theta is 130 degrees. Now notice, you can't use this formula as it is, right? We need to have it in degree radians. So the first thing you want to do is to convert, step 1, convert degrees to radian. Step 1. So to convert degrees to radian, as we know before, we multiply your degrees. So we have, so we have degrees multiplied by pi over 180. And the hint would be the degrees will more or less, they will factor out each other. So that's what tells you you're in the right path. So now we have 130 degrees multiplied by pi over 180 radians. which works out to be 13 pi over 8. It's 130 degrees. So now we can use our formula. A is equal to theta radius. So now theta is equal to 13 pi over 8. So this would be 13 pi over 8 multiplied by 6.7 centimeters, which works out to be, let's see what that be in a calculator here. 13, oh, I forget my pi here. Let's rewrite this a little bit neatly. 13 pi over 8 multiplied by 130 degrees. 13 pi divided by 8 multiplied by, oh no, radius is 130. Radius is 6.7. Okay, what do I have here? 13 pi, let's read it again. So 13 pi divided by 8 multiplied by 6.7. Okay, make sure I got this right here. It's going to give me 30. I'll double check my answer here. 130 be 13 over, oh, this should be 18. Now I know it's wrong. Should be 18, 13 over 18. Okay. Now, no, my calculation is off there. So 130 degrees, apology for that, is pi over 180, not pi over 13 pi over 18, not 13 pi over 8, because canceling those. Now that looks more correctly. Let's see now, 13 pi over 18 divided by 18 multiplied by 6.7, give me 15.2. Centimeters. It's 130 degrees. And final answer. So one of the features of using A is equal to theta r is that you need your angle to be in radians. Okay, you may want to try at this point questions 5 and 6 from your textbook. So we'll look at one example. So in your textbook, you can find that on page 494 and 495. So our next lesson, we'll be looking at converting between degrees and radian measure. Now, we know so far how to convert between degrees and radians. But here's a question. You're given theta is 255 degrees. Determine its measure in radians, given the exact measure and approximate value to the nearest hundredths. And a given theta minus 5 pi over 7 radians, sketch the angle, and determine its measure. So just a reminder that we know that 1 degree is equal to pi over 180 radians. And 1 radian is equal to 180 over pi. We also know that 360 degrees is 2 pi radians, or 180 degrees is equal to pi radians. So those are the facts we established. Now the part A, we can say that since 1 degree is equal to 180 over pi, so we can see radian. Oh, pi over 180, reverse here. So now we're going to convert that, we're going to use that fact as we did earlier. So 255 degrees will now be equal to 255 times pi over 180. So 255 degrees, okay, is equal to 255 multiplied by pi over 180 radians, which worked out to be, now if you worked all that out, it becomes 17 over 12 radians. But so 255 degrees is 17 over 12, oops. Or if you work that out, what would that be? 17 pi divided by 12, you got 4.45 radians. 4.45 radians. So 255 degrees is 4.45 radians, approximately or precisely. So that's A. Let's look at B. Now, the tell you here, given 5 pi over 7, negative 5 pi over 7 radians, sketch an angle. Now, one way of doing this, you know that 5 pi over 7, which is 5/7 of a pi radian. Now, we know from our circle, a unit circle, that pi is 180 degrees. So this is less than 1 radian. Okay. But we're going from a negative, right? So we're going now from negative. So it's less than 180. So it will be in quadrant 2. So negative 5 pi over 7. So we know this is 180 degrees here. So we'll do an estimate now. So 5/7 of, in this case, negative pi, you're going negative from here, you're going negative pi. right, which is 180 degrees. So we can put that as 5/7 multiplied by 180, because we know pi is 180. Okay, we established that over here. So pi radian is 180. So we can 5/7 negative, which gives me, what would that be? Let's work that out. 5 divided by 7 times 180. So negative 128 degrees. 128.57 degrees. So this is here, so it's between negative 90 and negative 180. So this so we know since, so we can conclude here, right? Since pi is equal to 180 degrees, we say 5/7. And then we'll do a sketch. So that's just sketch for that. So anytime you're given radian, for the first you may want to do a conversion to degrees. Later on, you'll get the concept of radian measure in your head. Now, by the way, if you look at a complete circle, right, 1 radian is approximately 57 degrees. And the way you do that is a 360 divided by 2 times pi, 57.29 degrees. So if we look at our 1 radian here is 57.29 degrees. Because 360 degrees is equal to 2 pi. So 1 radian is 360 degrees divided by 2 pi, which is equal to approximately 57.295 degrees. So you're looking at just over 6 radians. So to find how many radians there are, so 360 divided by how many degrees in a radian, around 6.28. So 6.28 radians, if we were to construct a radian here, is in one circle. Just a sidebar here, okay? And the last one, given theta is negative 8.25 radian, determine and measure the nearest tenth of a degree. Now, we know, we're just converting now radians to degrees. So let's convert radians to degree. So we know that 1 radian is equal to 180 degrees, or 180 over pi. Now, so negative 8.25 radians would be equal to negative 8.25 multiplied by 180 over pi. Now, what will that give us? So negative 8.25 multiplied by 180 divided by pi. Negative 472 degrees, so negative 472.69 degrees. Approximately. So negative 8.25 radians is approximately negative 472.69 degrees. So your task now is to attempt, check your understanding number 1 on page 489, and questions 5 and 6 on pages 494 and 495. So our goal today is to convert degrees and radian measures. Our next lesson, I'll be going over those questions and then going on to determining the trig ratios of angles in radians.